Hello everyone, welcome to Computer Science in Yoruba and English. In this lecture, we're going to be covering understanding database normalization, and we are going to attempt to provide answers to the following questions. What is database normalization? Why normalization? What is data redundancy? And how do we remove data redundancy? So, what is database normalization? Database normalization can be said to be a technique used in validating, organizing, and logically relating tables in a database in a bid to minimize data redundancy. So the question now is, what is data redundancy? Data redundancy simply means unnecessary repetition of similar data multiple times, which then leads to the following problems: unnecessary database growth, data integrity compromise, creation problems, updation problems, deletion problems. We'll talk about these problems in a bit, but before then, let's quickly look at how you can knowingly or unknowingly be a victim of data redundancy. Let's just assume you have a mini store and you need to store some information about products, and the kind of information you want to collect. You intend to store the product ID, you intend to store the product name, the quantity of the product, you need to store the category which the product belongs to, you need to store the name of the manager who manages that category, you need to store the phone number of that manager, you need to store the name of the supplier who supplies the product, and you need to store the phone number for that supplier. Someone who has no idea of what data redundancy is, who has no idea about what normalization is, you intend to just solve that problem of data storage at that particular point in time. And what you just want to do is just you want to store all this information all together so that you can retrieve them all together anytime you want to. So this is what your conception will look like. So we're going to add some data into it now. So we have this, we're adding data into that. So now that we've added all the necessary information into this, look at this. We have all the information about the product. We've stored them in just one table, in one entity, just like you want to do with your Microsoft Excel. It's fine, it's fine. But the problem is that this table is highly redundant, because we have a lot of information that should actually belong to separate entities. We have them stored in one entity, and that's what actually leads to redundancy in most cases, when you store information that belongs elsewhere in an entity where it does not belong. So that's what actually results in data redundancy. And if you look here, we've actually stored the information about the product. And basically about the product, you can see that this is fine for the product information, but this might not actually be enough. That's why we have to store this other information about the product. The problem now is that when I have the product managers, I have the phone number alongside with it. So as many products that belong to the toiletries category, I have to repeat this information for it. And this is not too good, because just assume you have about 1,000 other records to add. So it means that you have to repeat this information, these two information, 1,000 times. So before you know it, your database just keeps growing unnecessarily. Likewise, the supplier name is stored alongside the supplier phone number. And if you look at it, this supplier can supply more than one item, just like we've seen here. There are some suppliers that supply more than a particular item. For instance, this X detergent is supplied by this Mr. Abraham Davis, and we have X pencil by a Mr. Moses Cologne, and we have some other items. So just for as many items that this Mr. Abraham supplies, it means that I have to repeat this information multiple times alongside the phone number. So it means that I'm actually repeating this phone number for as many times that I need to. Just like in the case of storing the category information, this is taking a lot of time and resources to actually do. And the reason why we've ended up being a victim of redundancy? Yes, because we have information that should have belonged to separate entities. We have them stored in one. So if you think of entities now, if you have product is an entity, we have the manager, which has other information. We're just trying to keep this example simple. The manager can have the house address, the manager can have work email, the manager can have other information that you want to capture. It will be suicide for you to say you want to capture all those information in this single table. To keep it simple, I've only managed to store just the phone number here, and here I want to store just the phone number of the supplier. So this is what my data will look like without normalization, and that's why we say it's highly redundant, all because we've stored the information about the supplier alongside the product, and we've stored the information of the category manager alongside the product. So the big question is, how can we knowingly or unknowingly become a victim of data redundancy? And it's very simple. When we merge information that belongs to separate entities into one table, then we are most likely to become a victim of data redundancy. So let's quickly talk about the other problems that could arise from data redundancy. So we've talked about the insertion problem, but for emphasis, we'll quickly talk about the insertion problem again, also known as the insertion anomaly. So we have this. Let's just assume that we need to add some other 10 products that belongs to this toiletries category. It means that we need to enter the name of the manager who manages this category alongside his phone number. And so it means that we have to repeat this same data. We have to repeat it 10 different times. And like I said, it will take a lot of time. Not only time, it takes a lot of resources to actually do that. So what if there's a way to actually solve this problem, which we will talk about later on in this lecture? Another scenario to look at is, the supplier name is bound to each product, not the category. So we can actually see that if we have to enter 100 other products that this Mr. Abraham Davis supplies, it means that we have to enter the name and the phone number 100 times, and that's a lot of work to do. Takes time and resource. Another problem we need to look into is the updation problem, also known as the updation anomaly. So let's assume that we need to update some information about the phone number for one of the managers. So let's say this Mrs. Comfort, for instance, if our phone number has actually changed and we need to update this particular record, it means that we need to look for all records where she appears. Like for instance, here we have to check it. We have to check these two, and we have to, for many other records where she appears, we have to make sure we change the phone number to match the new phone number. So let's assume we have 1,000 other records in this table. It means that we have to change each and every one of these records to comply with the new phone number that she now uses. So, and if you look at this takes time and resource to actually solve the problem. Likewise, the supplier. Let's say supplier, for any of the suppliers' information, in this very case, the phone number of any of the suppliers change for any reason. It means that we have to edit the record for every line where that person exists. So let's say Mr. Abraham, for instance, we need to update the phone number. So it means that we have to change the phone number here. It means that we have to change the phone number here, and for as many other records that we need to. Let's say you have 1,000 records where Mr. Abraham Davis appears in. It means that we have to edit 1,000 records just to correct the phone number for Abraham Davis. And as you can see, this takes time and resources to execute. So remember, we talked about the fact that data redundancy can lead to data integrity compromise. So just like we've already seen that it's a lot of work to insert new data if you have redundant information in your table, and now we've seen that to even update that information is a lot of work to do when you have a large amount of data to deal with. In the course of modifying your data, it is very possible that you make mistakes while modifying data, and there are probabilities that you make mistakes unknowingly. So this actually compromises the integrity of the data eventually, because you have some correct information in some places and other places you have the information not correct. So the information can actually be inconsistent eventually. So we can actually say it can bring about inconsistency in the integrity of our data. So there's also the deletion problems, also known as deletion anomaly, that we need to look into. So let's consider this example. Let's say for one reason or the other we need to delete records for product ID 0003, 0005 and 0006. I intentionally chose the example because it has the same category manager. For 003 we have confectionaries, for 005 we have confectionaries, but for 006 we have antiseptic. So unfortunately we have these two different categories being managed by the same person. If for one reason or the other I have to delete these three records, unknowingly to me I'm wiping the records for Mrs. Elizabeth Richardson, and I might have no intention to do that. So it means that if I have to register another category, or if I have to bring in another category that belongs to maybe confectionaries or antiseptic, it means that I no longer have the record of Mrs. Elizabeth. So I have to do that all over again, something that I've already done before. So you can see that unknowingly to me, I intend to delete the records here for the products, but I'm also deleting the record for the category manager, and that is definitely not my intention. Let's consider another example. Let's say for instance I need to delete for one reason or the other products ID 0001 and 0009. If you notice, these two items I picked has the same supplier, Mr. Abraham Davis. If I delete this record, unknowingly to me I'm also deleting the records of the supplier, Mr. Abraham Davis. So somehow, if Mr. Abraham Davis brings in other products, the next stock, it means that I no longer have that information, just because I mistakenly or maybe intentionally or ignorantly deleted the record for Mr. Abraham Davis. But if I have actually done justice to my data modeling right from start, I won't fall victim of this kind of problem, and that's why normalization is very important. Having understood the problems that can result from data redundancy, I'm sure the question now is, how do we solve this problem? Maybe you're thinking what I'm thinking. From a general perspective, all I need to do is to break this table into separate entities so that I can manage them separately and reduce redundancy. So if you're thinking what I'm thinking, then it means you split this table into three. 1. The product table. 2. The category table. Then 3. The supplier table. One may want to ask, how come we still have redundant information in the product table? Normalization is not about eradicating data redundancy, it is to minimize it. It is practically impossible to fully eradicate redundancy in data. What we want to do is to be able to minimize it and manage it effectively. So it's not wrong if we have this information about the supplier, repeated for each product because each product has its own separate supplier. Having broken this table into 3 separate entities, it doesn't mean that we've totally normalized our data. That is just a simple application of what we've learned so far. To learn properly about normalization, we have what we call the normal forms, and these are rules that we apply to our data to conform with certain standards. So we have the first normal form, second normal form, third normal form, and maybe we'll learn about the advanced normal form called BCNF. In our coming lectures, we shall be discussing the normal forms, starting with the first normal form, and we shall be using this same example and see how we can make these conform with the first normal form. If you have any questions as regards anything we covered in this lecture, kindly use the comment section or send us an email at csctuts@gmail.com. Thank you. See you in the next lecture.